Hello guys, welcome back to Goe FPV. In today's episode we will build a 5-inch racing drone. I have here the GEPRACR, a GEPRC Racing frame kit, and this frame kit weighs only 79 grams. The aim for today's build is to reach a total weight under 500 grams. Okay, let's start by showing you which are the components that we will use in this drone. First, of course, is the FPV frame, and I already showed it to you. Now let's continue and show you what it will be in the middle of the drone. Recently I won some giveaway from Maps King. They are not sponsoring this video, but I'm really happy that I can make use of this stack. This is a mini stack actually, so I think it's a little bit lighter than a regular stack, but I really want to see how these are going to perform. So I have here the SZF7 flight controller, and here the SZ45 amps. This is a 6S 4-in-1 ESC, and combined with this flight controller I think they will be able to power up this drone. We will see. Next, for the video transmission system, I am going to use a video transmission unit from iFlight. This is a Sussex Force Mini VTX. It's a 600 milliwatts 5.8 gigahertz transmitter, and I hope this will do the job for our drone. Also, I am going to use the RunCam Racer Nano 4. This is a very tiny drone. I think it's a 10mm camera, but it's very nice that it comes with an adapter, so you can use it as a 19mm FPV camera, and this is analog, of course. And together with this VTX, I'm going to use this True RC. This is a Singularity 5.8 GHz MMCX, a short antenna for avoiding ripping it off at any crashes, and also to be a little bit lighter. Okay, now as a receiver, to be honest, I thought that I have a Nano RX, a crossfire receiver, but it turned out that I don't have any of this in my workshop, and I found out that I have a FR Sky receiver. This was installed in my first drone that's there on the wall. That 3-inch drone was my first drone, and it has on it this FR Sky or Fry Sky, I don't know how it is really called, and I will try to use it. I hope it works, we will see. And for the motors, I'm going to use some frame arm boards which have some LED lights. These are going to have a very interesting color, and together with this I will use these motors. These are not new, but are very good motors. These were on my Nazgul Evoque F5D drone, which I landed it in the sand and they got stuck because of the sand. I didn't think about that, so if you are going to fly at any beaches, don't land in sand. It's very messy job, so I was able to clean them out. But I also changed the motors on my F5D drone to 2306, and I just have these motors which I will make use of them in this build. These are Sing 2 from iFlight 2207 1855 kV. So these are good to be used with 6S batteries, and for the battery I'm going to use an Ovonic 1300 milliamps 130C, and I hope this will be able to power up this racing drone. Now let's get back to the building itself, and of course we will start by analyzing the frame and see how this is going to be all installed. It has a 20 by 20 stack mount, and I think all the boards will be installed in the middle, so the flight controller, the ESC and also the VTX will be installed in the middle, and we will see if everything has enough space inside here. But I think it's all right. We will see. Let's disassemble the frame and start by installing the stack. So first, the ESC, very nicely packed. It comes with the board and a lot of accessories. We have the XT60 connector, and also I see here there is a capacitor and also some garments. The flight controller also in a very beautiful box. We have the board and as usual we also have the wires and some garments as well. So first thing, we are going to install the garments. Okay, the garments for the ESC are installed. I also installed the garments for the flight controller, and I will just pre-install them in the frame to see how they fit. Now I will remove everything and I will start to assemble everything one by one. So here is the ESC, and first thing first is the capacitor, which I will install it. There are two holes right there, and I will install it on the other side. The white strip is indicating negative terminal, so be very careful to not invert the polarities. Okay, the capacitor is inserted. Now I will pre-tin the soldering iron. I will clean it first, and it will require a lot of heat, especially the negative terminal. Let's start. Now the positive terminal, which should work a lot faster. Okay, now let's prepare the XT60 connector. I will pre-tin the wires before soldering them to the ESC. Here I have to be very careful because I don't want the solder to be very tall. In that case, if the solder is very tall, it will touch the frame, and that's not good. Good, so let's clean it up now. Okay, for cleaning I will use isopropylic alcohol. I will cut the capacitor extra wires and everything is nice now. Next thing is to pre-tin the motor pads, and after that I will solder the first part of the motor wires. So the wires will be cut once here, and then solder here, here and onto the ESC. So we have 36 soldering to do. First thing first, we have to pre-tin the end of the wires before soldering them on the ESC. Okay, so all the wires are now soldered to the ESC. I will just clean it again and then install it in the frame to see which is the length I need to cut the wires. Before continuing to assemble the ESC and the motors, I need to cut, as I said, the wires at the correct length, and for that I pre-installed the stack in order to calculate the correct length of the wires. Okay, so now I will connect this board and the motor first for all of the 4 motors, because it will be easier for me to calculate the exact length that I need for the wires that are coming from the ESC. very important to clean the soldering joints, because if you don't clean them, you will not see clearly if there is any bridging between the soldering joints. After you clean them, it's very clear and easy to see if there is something wrong with them. So the next step is to add some shrink tubes to protect these connections from touching the frame, and I will use this nice kit I have with different sizes, and I hope I have a big enough shrink tube for this application. Let's see. It's very clean. The soldering joints will not touch the board. I will do this for the rest, and we will continue by cutting the wires from the ESC to the exact length to reach these joints on the other side. All the motors are now ready to be installed. Okay, so the motors are installed. I have the ESC wires. I will route them on their way and cut them to the correct length. So let's start. Very important, don't forget to first insert the heat shrink tube, otherwise you will not be able to insert it afterwards. So again, cut the heat shrink tube in 4 pieces. I will insert them to make sure I don't forget. And very important, try to put the heat shrinks as far as possible from the points you're going to solder, because it might get shrinked before you want to heat it up. Okay, now we can start soldering, and I will do this again making use of my third hand. Good. Okay, I will clean up these soldering joints, then try to set the heat shrink on top of the joints, and I think the ESC is ready to be set on the frame. Good guys, this is the power plant of the racing drone we are building today. So I will put this aside and we will start doing the flight controller setup. So I will check very quickly the wiring diagram of this FlySky XM Plus receiver, and also the wiring diagram of this flight controller, and I will start soldering the wires to it. Yeah, the position I have here is very inconvenient. Okay, the receiver is soldered. The next thing is the camera, and for that I will need to get out the camera itself. I want to see what wires they are providing here in the box. I need this wire with red, black and yellow wires, and I will not use the connector, so I will have to cut it away. So I will cut the connector like this, very easy, and I will strip the wires. Let's start again. We need to pre-tin the camera pads, which are here in this corner. We have ground, 5 volts, camera, input feed, and also the camera control, which I will not use in today's build. Perfect. The only thing that now we have to do is to also connect the VTX, and this also has a connector. So now let's see how this is going to be connected. Good. If I want to shorten it out later, I can just twist it. So the standard procedure, trim the wires pre-tin them with solder and then solder them onto the board. The pads for the video transmitter, according to the flight controller wiring diagram, are these ones here in the corner. So we have ground, 5 volts, VTX and T1. VTX is the video feed and T1 is the smart audio port. Good. And this should be it, but still there is one more thing, and it's very important too. Here on the other side of the board there is a bridge connection, and this bridge connection is used to enable the pit mode, and for that I will need to bridge the on pad with the middle pad. So let's do that very quickly. Perfect. They are bridged now. With pit mode I will be able to control if the VTX is turned on or off according to the specification of this flight controller, or if you're not able to turn it on or off, you're able to communicate with the video transmitter and also use pit mode, which lowers the power of the video transmitter where you're not arming the drone, so it will not transmit at full power and waste your battery or start to heat up very quickly. Before continuing, I would like to also clean the flight controller, and I will use the air compressor to blow the flight controller. I will do it right now. Good. The same for the... Alright, and also the VTX.
2 hours later.
Good, so now let's see how we should install the camera and the receiver, because those don't have a specific place to be mounted. I will check the frame kit to see what parts do I have for that. So I have 2 camera mounts. I don't know if there is any difference. Yes, it is. So one is for smaller cameras and one is for bigger cameras. And okay, good. So I will use the one for smaller cameras because I have a smaller camera. The camera is a perfect fit. It just reaches the end of this case. It's absolutely perfect. Now, also very important is where I place the receiver, and because I have the capacitor and also the antenna in the back, I will place the receiver in the front and I will just route these antennas under the front arms and I will tape them out together with the motor's arm guards. Let's insert the ESC because I want to see how everything comes together, and based on that I will decide how to install the receiver. So first a set of garments. Now I will insert the ESC. Perfect. And as for the flight controller, I already routed the... Oh, and one more thing that I really forgot about is the ESC cable. Okay. Okay, so the ESC is connected now. I can properly now install the stack and add the hex nuts. So I will do that now, and after that I will start installing the motors and also the receiver. I don't see anything out of order. I should have still some play, and I have some play. That's perfect. I don't know if this is good because it might add interferences into the ground. I might have to add some tape under the connector to make sure that doesn't happen. Okay, I think this is fine. Now let's start to put the motors onto the frame, and I will start installing them right now. On this particular frame, the motors only are screwed on with 3 screws. This is, I think, to reduce the total weight of the drone. Good, so all the motors are now installed on the frame. I will put the receiver on top like this, and one antenna will go under the drone. So I will put the antenna under the arm, one onto the right arm and the other one onto the left arm. Okay guys, so I finished installing all the components in this drone. I also installed the receiver antennas here onto the arms in the back of the drone. I haven't installed yet the propeller because the next step is to configure the drone in Betaflight. And after that we will take this drone to a test flight, and I will also show you how to build racing gates if you want to practice. I really like how this drone turned out, so one more thing I want to do is to put it on a scale and see how much does it weigh. So let's put it on the scale without battery and propellers and see how much it weighs. It's 267 grams, and if I add the battery on top of it, it's 471 grams. With propellers, maybe 480 grams. If you enjoyed my video so far, please take a moment and show some appreciation to my work. Hit the like and subscribe to my channel for future videos, and let's configure this drone in Betaflight now. Also, one more important thing is to check if you have any short circuit. It's recommended to use a smoke stopper, but I don't have one around, so I will just use my multimeter and I will check it into the diode mode if there is any short circuit. So if there is short circuit, it will make a sound like this. Otherwise, it will not make any sound. So let's test it out. So no short circuit. We can also test it with the battery, and let's hope it will not burst into flames. Let's see what happens when I plug the battery. Okay, so first thing that I'm going to do is to flash the latest firmware onto the board. So this is actually a T-Motor F7 board. It has a STM F722 chip on it, and I will flash it to the latest firmware. Okay, so the flashing finished successfully. It's calibrated. Looks like it is working, but it's reversed. It looks like if I pitch forward the drone in Betaflight, it pitches backwards, and this means that the axes are rotated. The flight controller is not installed in the correct position, but this can be easily fixed in configuration. So we will have to rotate the flight controller 180 degrees and also inverted 180 degrees, and we save the configuration, and now we should be fine. Now if I pitch forward, it pitches forward, left, right and backwards. Yaw also works correctly. Good, so this is the first step. Now the second step in configuring Betaflight, it's setting the ports. Okay, so the Maps SZ Mini F7 flight controller shows you here that for the FlySky receiver, which uses S-Bus, we should enable the UART5 as a serial receiver, so we will do that, serial RX, and the receiver is a serial based receiver and the provider is S-Bus. I will save this configuration, and now let's check if it's saved. Yes, and in receiver we should select receiver, that it's a serial receiver, and I will use S-Bus. This is already pre-configured since I flashed the firmware, so it technically speaking should work right now, but we will check this later after we bind the transmitters. For the video transmitter we have to select the UART1 because we use the T1 pad for the video transmitter communication wire, and so that we have to select the UART1 as a peripheral VTX IRC tram. This is the protocol that this VTX uses. And that's it. Save and reboot. And now the only thing it's mandatory to do is to go in the video transmitter tab and also load this VTX table and also do all the settings for your VTX. Next thing in the configuration tab, the craft name, it's GEPRACR. Very important, set the arm maximum angle to 180. We don't have GPS, we don't do in-flight accelerometer calibration. We already adjusted the board alignment and everything is set here. Save and reboot. Also, I did some adjustments for the fail-safe configuration. I changed it to land instead of drop in case of a fail-safe. Into the presets I will load 5-inch UAV tech. So I will search for UAV tech 5-inch race. This is the one that I will use. Medium build quality, I will select 1624. Okay, I will leave it as it is. Dynamic idle. Pick, agree, save and reboot. Good. Now that I have the presets, I will not adjust anything in the PIDs. So this is everything already set up. The receiver is set up. In the modes tab, I will have to update this after I bind the remote. And here in the motors, very important, I will have to test to see if the motors spin in the correct direction. Okay, so for this I need to connect the battery. Be very careful, don't install the propellers for this procedure. So I connected the battery and now I will enable the motors and start to check them out. Alright, so I have set up the motors, all the directions are set in the correct way and the bidirectional D-shot is enabled. Everything is correct. Next would be the OSD, but for that I need the goggles, which I don't have right now. So I will start by binding the ESC, and after that we will configure the OSD. Okay, so 10 years later I managed to bind the FlySky receiver to the radio master. I found out that we should downgrade the firmware because the latest firmware doesn't allow you to bind it to other radio controller than FlySky. Now the next thing is to set up the modes. So the arming, I will have to set the arming and the modes, the beeper, and also the launch control. So I will do that right now. Okay, so now everything is set up correctly. Arm, the modes, angle, horizon. I set up a beeper, the flip over after crash, which I will need in case I crash, and the launch control. This is all I set up here. Now the next thing is to set up the launch control. So for setting up the launch control, I will use the CLI. I already assigned the switch for launch control, and now I have to set some parameters. So first thing, I will set launch control mode as pitch only. Set launch Okay, I saved the settings, and now theoretically you can flip the launch control switch and then arm the drone, and with the throttle to the minimum you can set the angle of the drone by pitching forward, and then you take off by raising the throttle over 60% as I configured in the CLI. So we will see how this goes in the test flight. Next, the OSD tab, the battery voltages and the current consumption. Also the timer, the VTX temperature, which I want to monitor because I installed it between the ESC and the flight controller, and also the VTX configuration. And that's it. I will just hit save, and we are ready to test this drone. Okay, so we are now in the field to test this drone, and as I promised, I will show you how to build your own racing gates from regular stuff that you can find from your local stores. And I will put the drone aside. So what I'm using to build these gates are these PVC tubes. I choose this particularly because it's very easy to combine them with these 90 degrees fittings, and you can build your racing gates something like this. So you can combine these to create simple gates, or you can also create, by using T fittings, you can create double gates if you want. And I will show you how this is done. Okay, the first gate is already installed, and as I told you, we can add another gate on top of this one. You can use these fittings to configure the gates however you want. And the problem is that today I forgot to bring my to bring some metal sticks that I was inserting beforehand in the ground to hold everything together. Luckily I was able to just press the tubes directly into the ground and it sticks just fine. I think until the first crash, but that we will see. And this is a double gate, and next step is to add some color material on this horizontal tubes in order to be more visible from the drone camera.
So the itsy bitsy spider went up the spout again.
And yes, this is the moment when I totally lost the drone. Unfortunately, as you've seen on the DVR, I lost the signal in my goggles immediately after launching the drone, and I was not able to recover line of sight of it after getting out my goggles. The problem is exactly what you're seeing here on the screen. DJI Avata was hovering. I was intending to record the launch from a different perspective, and I didn't thought of the DJI Avata interfering with the signal from the analog video transmission system. So I lost it. I had no beeper, no GPS on it, no way to find it where it has crashed. I tried to track it from the videos that I have, but there was absolutely no way to track the exact location of it. I was able to search it around in the field, but as you see, the field is very dense in vegetables and there was no way to find it. I searched it together with my friends 3 days in a row, 4 hours every day almost, and no way of finding it. It might have ended inside a big bush and there is no way of finding it like that. There are a lot of bushes on that field and there are measured by me around 5,000 square meters to search for it, and I gave up after 3 days. This is it. Sometimes you have to pay for your mistakes, so take this lesson from my video and don't fly around digital video systems with an analog system, especially with the DJI O3 Air unit, or if you do this, please be very careful. Therefore, this is life, guys. You have to learn from your own mistakes sometimes, the easy way or the hard way. I hope you've enjoyed this build, so please subscribe to my channel, support my mission, and see you in the next videos.